Hi guys, trying to explain further electron configuration and electron notation. We're going to go over two different kinds. We're going to go over how to use electron configuration to do the notation and how to do the orbital notation with the direction of spin of the electrons. To start out first, make sure you do understand how to write the electron configuration. So make sure you have, so with this, your energy level 1 is only going to have an s orbital, that's the sphere or the circle, and that holds 2 electrons. So with that, you'll see that it says 1s2. The exponent for these is always going to be, your exponent is going to be your number of electrons, is your exponent. Then the S here, this is going to be your sub shell or suborbital. And then the number 1 on the side is going to be your energy level. And this is the distance from the nucleus. So as you increase how many shells you have, so if you have one, so if you're hydrogen and you have just one little shell, or if you add on to that and your lithium just underneath it, you have a second shell. Just the same as when we go down the period, how they increase in the shells they have. That's the same with quantum numbers. So it'd be n equals 1, then n equals 2, and so on and so forth, until you get to n equals 7. Once you've written out your electron configuration table on the side, make sure you draw the arrows coming down diagonally, and this is showing the direction in which you'll progress in writing your electron notation. That is the order in which the orbitals are filled. So if it's an S, P, D, or F orbital that's filled. So I'm going to continue drawing. I have my top arrows. I'm going to continue them down. Until I finish my table on the side. So now my table is complete. I know the order to go in. We're going to do a couple for practice. So a few that we're going to do, we'll start out a little easier and then we'll try and pick it up from there. So one of the first ones we're going to start out with is sodium. So with sodium on the periodic table is atomic number 11. So with that, you're going to need 11 different electrons. So sodium has 11. So it's going to have 11 electrons. So with that, I need to figure out how many, for my notation, how many orbitals, how many energy levels. So I'm going to put a box. In that box, we're going to start by learning how to write the electron notation. So we're going to start up here at the 1s2. So we're going to go 1s2. I now have 2 electrons. Next, I'm going to start at the top of the arrow and come down. So 1s2 to 2s2. That gives me 4 electrons. I'm going to go back up to the top arrow. 2p6. I now have 10 electrons. I need 1 more. So for this, it goes down to 3s2. But I don't need 2. I just need 1. So it can hold 2, but I just need 1. So it would be 3s1. And with that, the reason we're doing this is we're trying to find what the outermost energy level is, where the valence electrons are located. Is it in the S block? Is it in the D block? Is it in the P block? So thinking back, a shortcut version on our periodic table, we have the different blocks. Your alkali and your alkaline earth metals, those are the S block. When I say S block, I mean your valence electrons. That is the orbital in which they are. So S block is here. In the middle of the table, this is your D block. So your transition, that's your D block. Then your other side of the table, your other metals, your metalloids, halogens, nonmetals, and noble gases. Those are all P block. And the bottom of the table, that gets added right in here with other transition metals. This is going to be your F block. Okay. So we have this when we're looking at sodium. Sorry, not to scale. There we go. Hydrogen. So first you have hydrogen. After hydrogen comes lithium. And then after lithium, you're going to have sodium. So thinking back to when we talked about patterns we may see in groups or periods, if this is group 1, how many valence electrons would group 1 have? So you're thinking, group 1, I wonder what the numbers mean. 1 valence electron. So sodium fits into this group. So we see here the 3s1 right there at the top. That 3s1 is telling us, okay, the last energy level filled is 3, and there's 1 electron in it. There's 1 electron in that. So how many valence would it have? Either looking at my table or at my notation, sodium's going to have 1 outer electron. And for our Lewis dot structure, that's that Na with a singular dot next to it. And this is the Lewis structure. This is what we do on our periodic trends poster. Okay? Looking at trends, as we go down our table, you have period 1, period 2, period 3, all the way to 7. So as we increase in periods, we also increase in energy levels. So for sodium, we talked about it being S, and since in row 1, it's going to be S1, and we're in period 3. So we see that our valence electrons over here are what? Our valence electrons are 3s1. Okay? Take a minute. Think about it as you continue. So if you went underneath sodium, so you're going to have potassium. So potassium is in period 4. What would potassium be? If they all have S1, one thing changes. So potassium would be 4s1. Looking at patterns as you come down the table. After doing our electron notation, the other one that gets a little bit tricky is called orbital notation. This is also helping us find out the spins of the electrons and finding out what the valence are, what's available, where are they located. Orbital notation of sodium. So you're gonna have the lines given. So you're gonna have here, you'll have 1s, that's energy level 1, 1s. You're gonna have 2s. And then P, remember, P can hold up to 6. P can hold up to 6. So when you're drawing it, you're gonna have it say 2P, but then you're gonna provide it 3 spaces. And I'll separate with commas so we can clearly see how they're separated. And then our last one's going to be 3s. when we are drawing for our orbital notation, you want to make sure the spins are in opposite directions. So remember, it's a -1/2 spin. And to balance it out, the other is a +1/2 spin. When looking at the notes on your homework packet, it says at the top, number 1, electrons occupy the lowest energy orbitals first and then move on to the next one. That refers to here. It starts at level 1 and then it moves on. The second thing says orbitals are considered to be in the same shell if they have the same number for number 2. That's number 2 on your homework. Number 3 says an atom will gain or lose an electron in order to have 8. So we're looking at this to see, in the last shell, is this one going to have 8 or are they going to lose one so that they can have 8 in a lower energy level? So we're going to start out here. Remember, they have opposite spins. So we'll start out with our first one. So this one has 2 in it. That's the first one. Then you're going to draw the arrow in the opposite direction. So this is 1s2. For 2s, remember we start up and then we go down. That's 2s2. Then we have 2p6. When we're filling 2p6, you want to make sure everyone's got a piece of the pizza before you give everyone seconds. So you start out, this one has 1. The next one, you give them 1 and finish. Okay? But then it's, okay, I have 2, 4, 5, 6, 7. I only have 7 electrons, so I have to keep going. 2p6, it can hold 6. So I'm going to finish drawing. You cannot skip one in the middle and skip ahead. You need to make sure that all are filled before moving on. Okay, so now we have 10. We need 11. So for our last one for 3s, we're going to have our last one up at the top. So 3s1. With the valence electrons, so sodium has 1 valence electron. Sodium has 1. And that's seen here, the highest energy level is energy level 3. And it just so happens to be an s orbital also. But it's energy level 3 for sodium. So this is an example of how you would draw the spins. If you were to continue with another element, you would continue writing out the rest for an entire notation. The transition metals can get pretty long. That's where you get into the D or the F orbitals. But from this, you take the electron notation to create your orbital notation to C. So there'd be 1 electron on the outside. To get to the octet rule, sodium would have to lose 1 electron to get that octet rule. So if it lost its 3s and it just had 2s and 2p, it would then have 8 because it has 6 from p and 2 from there. So this would be its 8 if it lost 1. Okay? I hope that helped. Bring any questions to class if you have additional clarifications.